A conventional current of 6 amps is run clockwise in a circular loop of wire in the XY plane, with a center at the origin and the radius of 0.8 meters, or 0.08 meters. Another loop of wire with its center at the origin on the same plane has a radius of 0.02 meters. How much current must run counterclockwise in the smaller loop for the magnetic field at the origin to be zero? So I've already drawn the diagram. This is our larger loop. This is our smaller loop. So we know using the law of Biot and Savart that we can determine the magnetic field at any point on a wire using this equation. Now, so knowing that we can use this, we do the cross product. Using the cross product, because it's at the very center of the loop, it'll just give us this, mu naught over 4 pi times I dl sine theta over r squared. Since we're looking directly at the center, it's at a 90-degree angle. Since this is easy, sine is equal to 1, so we can just kind of ignore it. Then, since r squared, I, mu naught, and 4 pi are all constants, we just pull them out of the integral, and this symbol means that we're integrating from 0 to 2 pi over r, 2 pi r, which is the full circle, or you can just do it like this. It means the same thing. When you finish integrating, it'll give you this value, mu naught over 4 pi I over r squared times 2 pi r. Now, these r's cancel, and it'll leave us with, and this pi cancels, this 2 cancels with this becomes 2, and we end up with mu naught over 2 I over r times n, where n is the number of loops of wire. Well, each loop is only 1, so we can kind of just ignore it. Now, we're looking for the point at which both of these cancel to give you 0. So we're solving for the small magnetic field in order to cancel out the large magnetic field. So what do? Well, first things first, we plug in the equation and what we know. So we know that this is the equation for one loop and this is the equation for the other. So we're just looking for the current of I, so we just divide by these values, and these two cancel because they're the same number of loops, and then we just plug in what we were given, and we get 1.5 amps, and that will cancel out the magnetic field in the center.